Okay.
So what I want to do is I kind of want to unpack the idea of context engineering in a way that makes sense for folks.
Mm-hmm.
Promode is a context engineering infrastructure. So I thought it'd be cool if we could kind of like frame this from some familiar things that people understand. So I want to start with your chat LLM. So this is Claude, this is ChatGPT, this is Gemini, this is Grok. So there's kind of two main types of models. One is a reasoning model and one is a non-reasoning model. Uh, in a reasoning model, you might ask it a question, and a reasoning model does not take your question at face value. They said, okay, Heather was asking for this thing. I think that this is kind of where she was headed based off of some other training data that I have to where I know what people actually want, and then it spits out your answer. This is a very familiar thing that we've all done a million times. Uh, so, like, when it comes to how do we evaluate this thing, there's some interesting. I was actually looking up some kind of like really interesting uh, numbers in here. So, factual information. We've talked in the past about how a large language model is not an oracle. It actually doesn't have like it doesn't have a source of factual data per se. Um, when something shows up in a large language model as it producing a fact in the way that like Google would, I was reading that that oftentimes needs to show up as 100 unique variations of the same data. So this like an example of this would be like,
Mm.
what is Nikola Tesla's birth year? Well, there are so many articles on the internet that have him. You've got thousands and thousands of different variations of Nikola Tesla's birth year. Okay. Um, but this was interesting. I was just kind of like wondering, well, okay, let's say we want AI to know that ProMode is a context engineering platform. So the next time somebody builds a model, and let's say like the likelihood that they choose any of ProMode's content to train their model, first off, is super low. I mean, we can all agree on that. We're not going to waste the GPUs on whatever these two dummies are doing. Uh, so it's probably not going to be a part of the training data set, and certainly is not going to be mentioned 100 different ways, right? So that
Yeah.
probably will not show up as a quote unquote fact in the training data. So, a large language model is just pattern recognition. So in the case of Nikola Tesla's birthday, it's shown up over 100 different ways as that being his birthday. And that's like sort of built into the probability of that particular model, but it's not,
Mm-hmm.
that information is not being retrieved from somewhere. It's not like going and looking, let me go into my training data book and find
Yeah.
Nikola Tesla's birthday. That's not how it works. So when something appears as fact, it is only because in the original training data set, it appeared enough variations of the same way.
Yeah. And I think that's kind of how our brains work.
Yes, exactly.
Like if you ask me what's the capital of Texas, I'm going to tell you as if it is a fact, it's Austin.
Hmm.
It's the capital of Texas. Whether that is a hardcore fact or not is yet to be determined.
And you learned that fact through maybe looking at a map, through singing a song or something like that. Like it.
Because I've probably, my guess is I have heard it, seen it, thought about it at least 100 times
Exactly.
through the course of my life. So
Yes.
I've got this, you know, this vast library of stuff happening in my brain that says this is a fact. It's Austin.
And furthermore, probably none of those library associations in your brain have anything to do with local politics. Like a capital is a representation of like the federal government, and like it's local politics. So this is like the seat of government for this state. It like your understanding of Austin as the capital of Texas probably has nothing to do with what it actually is.
Right.
It's not in the brain category of federalism. You know what I mean?
Right. Exactly. Yeah. It's in the rote memorization stuff from lists in grade
Yep. I
school
went to a
and
bachelorette party
that
in
kind of thing.
Austin. I looked at a map. I like it's those things that are completely unrelated to what it means to be the capital of a state.
Yeah, because now I'm thinking Joe Rogan moved to Austin. He's got the comedy place there now, and I would like in music, like that contextual understanding that's associated. Whereas if you asked me a question that has a fact as an answer, but it's something I haven't studied, and maybe I think I know, like a Jeopardy
Hmm.
question, right? Something that isn't as obvious. I'm going to guess, like if you asked, I don't know, who was the 15th president? I unless I have memorized all of the presidents, I don't know that, but I could take a guess based on things I do know,
Exactly.
right? And but I would know that's not a fact because I don't have a massive amount of data
Hmm.
points happening to tell me that.
Exactly. So the limitations on our accuracy and quality for this general setup is we're purely limited by the training data of that model. So if we want to take any actions and the actions that we want to take, the information we want to know, whatever thing we want to occur, if it was not present enough in enough variations at a high enough volume in the training data, we're going to have lower accuracy and quality in this workflow. So, one of the ways that AI engineers get around this is with agents. So, the difference between an agent and that just standard LLM experience is that agents have tools. So, an agent is basically like a workflow, like a documented workflow, and an agent is powered by an LLM. Just like the other chat example, that could be a reasoning model or a non reasoning model. So in our reasoning workflow, they reconfigure our question for us. In a non-reasoning workflow, the yellow cards are the user. Um, the difference here is that we're going to give these models some tools they can use. So if it's not in the training data, we want to like overcome that issue, that limitation, we're going to give these agents tools that they can use. So let's say they can search the web, they can query Google Scholar, or they can make an API call somewhere. In the case of a
Mm,
non reasoning agent, the user actually defines the tools that they want that agent to use. Um, if and you have to give
mm,
these agents tools. That's probably getting a little bit too technical. But like with a reasoning agent, they will choose their own tools and how to use them. So you're kind of in a black box with the tools, but we are able to pull in information that maybe wasn't in the training data. So we're kind of moving towards using an LLM as a computer for computing information that came from these tools. And so we're getting just richer context because we're able to pull something in, analyze and compute it in the event that it wasn't in that model's original training data.
mm.
We run into some quality and accuracy issues here as it relates to the tools. So we're pulling in new data that we're assuming wasn't in the model's original training data. And but we also kind of don't know the quality of this data. So we can do things like use Google Scholar and we could have a rough idea that this is going to be a quality data, but just a general web search, you're in the wild, wild west there. Who knows how quality that is? So you might
Mhm.
be supplementing lack of training data with poor quality tool data as well. Uh, and then furthermore, there's nothing really to analyze this data that's coming from the tools. There's really nothing to check it against aside from the original question, which is also problematic. So you might ask a question, it might pull all of this. You really don't know what this agent skipped over. Like, what didn't you pull that I might have wanted?
Uh-huh.
because you're only kind of going off this initial question. There's not a rich enough association between what comes back here and what goes into this answer. Again, still a little bit of a black box. Any questions here?
Mhm. So am I understanding, like, the left side is least control?
Yes, this is like biggest
And
black box. Anytime you use a reasoning model, your black box gets a little bit bigger.
okay, so least control, and then the right side would be more control,
Hmm.
okay? Because you have hand-picked, greenlit tools that are allowed to access your training data and inform your outputs.
Totally. Yep. You're not allowing the reasoning model to like override what you're, in the reasoning branch,
Mhm.
you're basically saying, hey, you're allowed to override my question. And like, if this doesn't make sense.
Okay, more guardrails on the right,
Hmm.
and we're starting to think of it more as a compute layer as opposed to
Relying only on the training
an
data.
answer
Yep,
machine. Yeah.
exactly. Okay. Now let's talk about context engineering. Um,
I knew you were gonna blow it out of the water.
so context engineering solves for both of those things. So both you can still use tools with context engineering, but you have something to reference those tools against. So in this case, instead of
Mhm.
question and answer, instead of prompt and response, you have workflows. And workflows are made up of a bunch of different components. So I'll just walk through some examples of this. So in context engineering, instead of a prompt or question, we actually have a workflow for a category of task. And so here we have two sides. We have tools. So we have a tool shed that can be chosen from. So let's say we have tasks A through Z. Um, for task A, we always use these three tools. So that always gets pushed into the workflow. Another thing that you can have with context engineering is a data mine. So you can have your own data set that you inject into this. So if because it's kind of scary to just rely on tools, super scary to just rely on training data. So, by having a repository of whatever data goes into this task for your company, for your family, for your whatever, you have this data mine here. And so you've got a big data mine for tasks A through Z. And for task A, we want to actually inject these three pieces of data from our data mine. This workflow sets off. And so we have all generally you want to have mainly non reasoning agents and LLMs throughout this whole workflow because you're actually feeding them training data. So you kind of don't want them to go looking in their own shit as much as possible. So you want to restrict this to non reasoning and give really specific step by step. So you would maybe for this non reasoning agent, you would say, do a web search. If you don't find any primary sources, do a Google Scholar search. If you don't find any primary sources, do an API call to JAMA, for example. Uh, And then this non reasoning LLM will then pull in these three pieces of source data and be told, this is your training data. Like, ignore past training data, like, wipe your memory. This is your training data for task A.
Mhm.
And then we have a third AI model down here that would then take each of the tools that were called. It will check those tools against the source data from the data mine, analyze all of that data, and assemble an entirely new context to be used. So we've created new training data for our LLM. We've done tool calls. We've analyzed both of those things together. And now we have created new context, which will be the training data. So then this becomes like super training data for another LLM. And that LLM is the output LLM. So here we've got one, two, three, we've got four AI models that are going into task A, and they are analyzing and synthesizing new training data that you provided against tools that were called by an agent and reassembled into an entirely new training data model that is used to complete your task.
Mhm.
And so when we evaluate this, you'll notice that our evaluation protocol has uh, zero black boxes. There are no black boxes because we have a data mine as training data. So if we evaluate it and we don't like this answer, we have the answer for why we don't like that answer, and it's in our
Mm.
data mine.
Okay, so this graphic, I'm assuming this diagram is the most simple form of this.
Yes, yeah.
Yeah. So the number of LLMs can be greater,
Mm-hmm.
all of them.
Yep.
The size of the data mine can be expansive.
Mm-hmm.
The source data, 1, 2, 3, could be 1 through 1,000.
Yep. Exactly.
Okay. But this is the basic principle of context engineering, and the reason for going through this effort is higher accuracy, more unique content, more unique outputs.
Yes, just quality on all fronts. Uh,
Yeah,
this is like this basic setup is the difference between that MIT study being a 95% failure rate and a 95% success rate. Like this is how
totally.
every enterprise AI deployment will look like this in 10 years. There's zero
Mhm.
doubt in my mind. This basic workflow right here is the key differentiator between the promises we hear about AI from, people like Sam Altman and the reality on the ground. Like, why isn't this thing working for me?